With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given that consider the circuit shown below, which where all the resistances are of kilo ohm. Now we need, if the current of 1 milliampere flows through the resistance marked X, what is the potential difference measured between P and Q? We need to find what is the potential difference across P and Q. Now what is given? So it is given that here the value of the current is 1 milliampere. So it is flowing through here 1 milliampere. And what is the value of the resistance? It is 1 kilo ohm for all the part. So we know that first of all we will not be writing. First of all we should know that if you multiply milli with kilo, so milli is 10 raised to the power minus 3 and kilo is 10 raised to the power 3. So they would cancel and turn out to be 1. Okay, we should remember this fact. Now here we know that, so what would be the potential difference here? So we can say that if we mark this as to be our value V1, so we can say that V1 would be equals to I into R. So I value is 1 milli and it is 1 kilo ohm. So if we multiply 1 with 1, it would be 1. That means 1 volt. So here the potential difference across these ends. So this is our V1. Now what would be the potential difference here? V2. So here the current would be same because they would be in series. So current would be same. That means 1 milliampere current would be going here. 1 milliampere. So what would be the potential difference V2? So we can say that V2 would be equals to I into R. Now I value is 1 milli and this milliampere and resistance value is 1 kilo ohm. If we multiply these two, so milli and kilo would be equals to 1 and then we will be getting 1 volt. So this is our 1 volt, which is V2. Now let's say the potential here is V3. So what would be the value of the potential V3? We just write here. So it would be the sum of the potential this plus this. Why? Because if we apply the Kirchhoff this KVL, if we apply into this circuit, so we can say that potential difference across these circuit, or we can say that net potential would be 0. So here the potential is 1 volt and here the potential drop is 1. So it would be 1 plus 1. That means 2 would be occurring here. So we can say that it would be 2 volt. This is our V2. Now what would be the current which is flowing through here? So current would be equals to V divided by R. So we say that current I3, this would be equals to V divided by R. R value is 1 kilo ohm divided by 10 raised to the power minus 3. That means 10 raised to the power 3. Because resistance value is 1 kilo ohm. So V divided by the resistance. So it would be 2 into 10 raised to the power minus 3. That means 2 milliampere. That means 2 milliampere current is flowing here. 2 milliampere. Now here it was going 1 milliampere. This is milli. So what was the current into this branch? It would be equals to 2 plus 1. That means 3 milliampere. So what would be the potential difference in, if we say this is our V3 and let's say this is our V4. In the V4, what is the potential difference? V4. So V4 would be equals to I into R. Current value is, we have already written current value would be 3 and resistance value is 1. 3 multiplied by 1 would be equals to 3. So 3 volts. So what would be the potential difference? This is our V4. So what would be the potential difference here? That means V5. So we can say that if we apply the KVL into this loop, so we can say that V5 would be the sum of potential difference for this part and this part. Here it is 3 and here it is 2. So we can say that V5 would be equals to 3 plus 2. That means it would be equals to 5 volt. Now if this is our V5, this is our 5 volt. So what would be the current I5 into this branch? Because we know the potential difference, we know the resistance. So I5 value would be equals to V5, which is 5 divided by resistance, which is 10 raised to the power 3. So it would be 5 milliampere. So that means the current which is going through this part is 5 milliampere. So this is, we just write it to be 5 milliampere. Now if we apply the junction rule, 3 is going here, 5 is going here. That means 8 would be coming from here. So we can say that 8 milliampere is coming from here. And what would be the potential here? So this is our V5. So this would be our V6. So what would be the value of V6? I into R, simple. What is the current? 8 milliampere. And what is the resistance value? 1. So it would be equals to 8 volt. Again, we apply our KVL to get the potential. This is 6, this is 7, V7. So V7 would be by the KVL, it would be V6 plus V5. So what is V6? V6 is 8. What is V5? It is 5. So we can say that our V7, this would be equals to 8 plus 5. That means 13 volt. Now this is our 13 volt. So what would be the current here? I7. Similarly, we can calculate our I7. This would be equals to 13 divided by 10 raised to the power 3. That means 13 milliampere. So that means here the current which is going is 13 milliampere. 13 milliampere. Now here the current is 8 and here the current is 13. So what was the current which was coming here? 8 plus 13. 8 plus 13 would be equals to 21. So we can say that 21 milliampere current is flowing through this part. So what would be the potential? V8. So we can say that our V8 would be equals to I into R simple. What is current? Current is 21. And what is resistance? It is 1. Because milli into kilo would be equals to 1. So it would be equals to 21 volt. Now if this is our V8, so what would be the potential which would be occurring across these ends? So it would be, if we apply KVL, it would be V8 plus V7. So we can say that our V9 would be equals to V8 plus V7. So if we add this would turn out to be, if we add this would be 34 volts. And this 34 volts is the potential difference across these resistors, or we can say that this is the same potential difference across P and Q. So which is the correct option? D would be the correct option. Hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.